it and just see how,
Just start recording.
yeah. Yeah, see how good or how bad it is. I know that
Is this Mike? Is this a mirrored surface already?
it's a mirror that Tom worked on, and I guess he didn't want to finish it because it wasn't fun anymore, I guess. And so it's I sent the test out to you guys. It's got a big hill and it goes down and it's got a rise and then it's got to fall off at the.
So he doesn't consider it done.
What?
He doesn't consider it done.
No.
Okay.
So because of the interferometer, I guess I'm able to see certain things. So I'll start on work on it. The problem I see with working this mirror is not necessarily the focal ratio. It's because it's so short where I have to put the polishing stand. I can't just take the tester off and do polishing on it and, you know, put things back together. I have to move the stand because there's not enough room. It's F3.3 10 inches, you know. It's not very far. But I'll work on it. I'll work on it from the outside in.
Okay.
That's what my plan is.
Is this a 2-inch thick mirror?
This is a full thickness mirror.
So it should be about 1.25 inches.
Yeah.
1 3/4.
It's, you know, it's about that thick. Weighs a bit.
It'd be 2 inches if it was a 12-inch mirror.
Yeah. So anyways, you know, we'll see how it works out.
Okay.
So Mike, what's your Windy City's observatory schedule for programs?
Well, let's see here. I have more time to put together the thing there, but while I was waiting on the airlines, they have a power outlet on everybody's seat. So I kind of more or less got more done with it. When I start talking about a subject, and I've told you this before, you know, I'll say, okay, I'm going to talk about this. And then I start doing research and I start branching out different ways because there's so many interesting things to see about the, you know, the subject. And I learned a few things that I hadn't before. It's not uncommon because I'm, you know, kind of sort of, you know, challenged when it comes to learning things. But, you know, I'll throw this up and I'll go quickly through it.
So do you have a normal schedule that you're trying to keep on which Monday of the month that you're trying to?
It's on every second Monday. Okay, hold a second here. And this is a good test because you said that I was not putting it full screen. So I'm going to go back, do a share screen. Okay.
You got to do the slideshow somehow.
Okay, so yeah, I'll do the slideshow, which is this. Okay, is it full screen?
No.
Because it looks full screen to me on this.
So maybe you have to choose a different window. If you share a different window.
Okay, hold on here.
It looks full screen to me. You know, if you go down to that icon of the fourth one over next to the 66%, click on that icon, it'll just expand the slide to the full screen.
Who, me or him?
Yeah, whoever's showing that slide.
I am.
Okay.
Okay, so let's see here.
Click on that icon.
Okay, hold a second here. Stop share.
Depends on which window he's going to share.
Yeah, right. Okay,
PowerPoint
so,
opens up two
so-
windows, maybe.
okay, so let me just do this here. Okay, here we go. Okay, so you see the screen.
Yeah.
Then
PowerPoint
go to-
screen.
See down
Okay.
at the bottom bar there,
Oh,
right
yes,
next to the 60, yeah, to the left. No, not that, not that. Put that back. There, go to the left of the 62. One more. There, press that.
that's what I did.
Oh, nothing happens?
But it might open up in a different window, maybe.
Huh.
Ah,
you have to
okay,
share-
let me see.
You have
Okay,
to share that window.
there, this one. Okay, is it full screen?
Yeah.
Not yet.
Okay.
No, not yet.
No, no.
You guys are all full screen, but the site isn't.
You're not sharing yet.
Okay, hold a second.
1001, 1002, 1000.
Okay, hold a second. This one right here. Okay.
Nope.
So that shows the,
The PowerPoint
Okay.
window.
Yeah.
okay, so your screen sharing, I'm going to,
There.
okay, now I hit slideshow.
Yeah.
Is it full screen?
No,
No.
nothing changed.
So, Mike, you have to find another window under
Yeah.
share screen. And, you know, I don't like the way Zoom hides some of the windows. You have to go down on the side to find more windows sometimes.
Yeah.
It's not obvious which windows are available.
Okay, hold a second.
So, Robert, how you doing?
Doing
Oh, here it
well, doing well.
Good, good.
There you are. Now it's full screen.
That's good,
Okay.
yeah.
Okay,
There you go.
so I, through the purpose, what's up in the sky? This was done by an iPhone with a 13-inch zoom hole reflector. So it's going to talk about things about the orbit size and all that.
Cool.
And have this here, you know, in case people don't know, it's 1/4 the diameter of Earth, but it's 30 Earth diameters away. The mass is 1/84th, which I thought it would be more, but you know.
You know what, Mike? I disagree that the moon moves through the sky at 0.56 degrees per hour.
It does.
I mean, if I look up at the moon, it looks like it moves at 15 degrees per hour.
With respect to the sky, in other words, through the sky position, it's 0.56.
It's orbit. It's orbit around the
Yeah,
Earth.
instead of the Earth's rotation, which is 15 degrees per
Yeah,
hour.
but as it moves, okay, if it's right next to a star, it's going to be half a degree away from it in an hour.
Right.
Right. So I'll have to make sure. It's got a liquid core, people say now.
Really?
Yeah.
Wow.
I didn't know that.
Yeah,
I
I didn't
thought
know
it-
it either. I saw it on the website. And this is interesting.
Well, if it's on the internet, it's got to be true.
Well, kind of, sort of, you know, more than one place. On the surface, it's got thorium, polonium, iron, sodium, and water and other elements. And I thought that was interesting that not only can the dust cause you cancer from, you know, being ragged, but polonium on the moon and looking at different maps of the moon, there's large thorium deposits and other radioactive deposits that they've seen. Now, whether large means it's enough to go and fry you, or is it just there in trace amounts, but there's some interesting elements there that I didn't realize. I thought it was,
I would think that the Apollo astronauts would have measured radioactivity on the moon when they were there. I wonder.
what they've done is the orbiter has detected radioactivity in the form of fast and slow neutron and gamma rays. be emitted. Now, it's not that much, but the fact that they discovered that, and there's maps of it on the moon, that in my research, you can see, oh, wow, yeah. And the thorium and some of the other stuff is sort of like in one area for some reason, but it's interesting. And this one here, most people forget, you know, the moon looks bright, but this is what Apollo took a picture of the moon, you know, in front of the Earth. It's not, you know, it's pretty dark.
So Apollo got that far away from the moon to take a picture like that, huh?
Yeah, yeah. I think it had to be. Well, I don't know. It was
Maybe
a picture. It's a picture somebody took. Okay.
I think
I
think the Discovery mission was that recently that satellite that was put up and taking a look at the whole Earth at once.
Okay, then I need to go change my notes. Maybe I read that wrong. Thank you for editing this. Now here's another thing too. These are notes from the guys on the moon seeing stuff. A small amount of atmospheric glow that they could see. So the moon has a certain amount of atmosphere. It's extremely small, but there's still some, and it was, you know, this is from on the moon that they did. Okay. Libration was discovered by how do you pronounce this guy's name? Hevelius. Anyways, there's some information that they said that Galileo or Harriot might have noticed it, but you know, it wasn't written down. So there's this movie I'm going to go run, which is a GIF, which shows the moon during a full month, where you can see it going back and forth and do this.
Yeah, we've done that on our Monday programs. We've shown the moon doing that libration thing.
Right. So then I'm going to talk about the moon occultations and stuff like that, and other things too. And then I started looking, and okay, I just did a search who did the first map of the moon. So that was kind of, it led me down another area. And you know, because when we all see the moon, there's a bunch of features. You can see kind of like the bunny on the moon and stuff like that. And you would have thought that you know, the ancient Greeks would have noticed it, or the Romans, but I guess they didn't see it that way. This is the first scientific lunar map by William Gilbert. This predates the telescope. So I thought that was interesting. I was kind of
like a Halloween pumpkin.
Yeah. But so the first telescopic drawing was Thomas Harriot, as I discovered, and I don't think that people took him that seriously because he was a cartographer. He wasn't an artist, and he never published his work because of the various things that happened around his life, like getting thrown in prison for knowing Guy Fawkes and all that. And also, I think a lot of people just thought that they weren't all that great because they were two-dimensional. Okay, now this is a more accurate one after, you know, I started studying it more.
So Mike, I think I should interrupt you and just check with Robert and Ed about their adventures with their equipment before because we can see you let us know when your program is on.
Okay, I stopped share so that they can throw up whatever they want.
Yeah, so I just wanted to make sure that they get through
They had a
something.
chance to talk.
So Ed, you've been playing around with your telescope at all? It's been pretty windy out there and not the best weather, but did you get any luck with doing auto guiding?
Yes and no. I got partway there. I think the equipment is coming up, but the camera, the auto guide camera is not seeing anything. I got a response back from PhD2 that in the 16 seconds or so, it found nothing and therefore is shutting down. And I was wondering, is there a mode I can go into where I can actually see what the auto guiding camera is seeing?
Well, first of all, I think a sanity check is during the day with your guide scope, and just look at a distant object. You should be able to see something on there. You'll have to adjust the gain lower and the speed faster, but you should be able to get something that you'll see like a picture. And in some cases, I'll just, I put it on the moon. Okay, and again, you know, decrease the gain and increase the shutter speed. And you could see.
Does your guide camera work on a pickoff from the main camera, or is it through a separate scope?
It's two separate scopes.
Okay, okay, good. Keep going.
I didn't understand, Mike.
Well, you're saying that the camera,
PhD2?
yeah, PhD2 basically will show you whatever it's seeing on the screen.
I know. Is there something I have to click on to do that?
Yeah, you have to select that camera.
Yeah.
You know, right now I go to looping and looping is not finding a star on the auto guider.
Okay, but if you don't see anything on the screen, okay, like dots or circles or anything like that, then of course it's not going to find anything because it looks for a very, you know, a bright small object. But I've done this in the past where during the day where I've put you know, just shown the telescope at a distant object or even the moon. The moon's a good one, and you should be able to see a picture of the moon on there as it goes through looping. It's just
Well,
that.
I think that's the problem. I think maybe it says the camera's working, but I don't think the camera is truly working.
Okay,
The
well,
auto
hold a second.
guide camera. Sorry.
Okay. First of all, you know, with the PhD guiding, put it on where the moon is. Okay. You know, I don't know if you know if your guide scope is pointed exactly at the same direction as your main telescope, but you should be able to get something going with the moon. It'll be blasted white, okay, initially, because normally you're setting things up for a faint object. And but when you get it on there, you have the same facility as any other control program where you're able to adjust the speed, the gain of it, and the time. And so I would set it up for gain of like 2 to 5% and a speed of let's say 500th of a second or something like that, and point your telescope, that is your guide scope, at the moon. And the first thing you should be able to see, it should go from dark to bright white. Okay. And if it's focused, you should be able to see the edge of the moon. Even if it's overexposed, you'll see a sharp edge on there. And so what I would do, the sequence is move it, look at the moon tonight, okay, because I'm not sure if the moon's going to still be up that late. Okay, if you see the moon at all, okay, lower your gain a little bit and increase the speed of your camera to where you can get a reasonable exposed image of the moon. Then you can start focusing it, because if you're out of focus a lot, PhD guiding won't see anything because it's not bright enough to see anything.
Is that guiding going to be independent of the main camera then? The gain and the time?
Oh, yeah. Yeah, PhD guiding in there, yes. Yeah, the controls for PhD guiding relates to the camera you're using as the guider camera, which in your case is the MM120.
Okay.
But you could do that at the day in the daytime too, because
Better,
you're
I
saying
think, at
that-
night though.
Yeah, but okay, here's another thing too. Go to the Brainiac hot button and see what the gain is set for. If it was initially set for, very low,
Yeah.
that could
Oh,
be
it's
the
in.
reason why.
Yeah. Yeah. Okay. I'm
Yeah.
in the process of making dinner here. I got to pull it out of the oven.
Okay. And while
All
you're
right.
at it, reset the game.
Robert, your turn to throw something up on the board. Hi, Tim.
Hi,
Oh, hi, Tim.
Hey,
hi.
So, you're muted, Robert. Still muted, Bob. Bob, still muted.
I
you
got
go.
a cold. I'm just getting over a cold. I don't want to sit here hacking
Oh,
while people are talking.
Don't spread it to us. Mm.
Listen, if it spreads to you, there's something really weird going on.
very-
Anyway, I wanna thank Jerry, first of all, Jerry, for your input on this switch for the observatory, and we wired it, went ahead and wired it, and it works perfectly.
Yeah, it looked good.
So I'll get into that in a minute, but I'll just quickly update you on our observatory here, which has really been going great, and people are just loving it. I mean, it's amazing the response here to the observatory, and people coming out and doing things. And there's some unanticipated or unintended consequences, which actually have been very good. Where we are right now, as far as the observatory is concerned, the observatory itself and the telescope are all up and running and functional. Where we're headed now, and on Tuesday, I'm sorry, Thursday afternoon, I'll be meeting with our IT guy here, and we're going to set up all the electronics necessary to transfer the video image into this room where people will be able to sit and watch it. And also we'll be, I'm working on a remote control for the telescope, so I'll be able to remotely control the telescope from that room as well. So we'll get all that going. The room is being totally refurbished, and they're putting up a couple of ultra high definition 85-inch TVs. So we're going to be able to put these images on these big TVs. And so I think once it gets done and going, it's going to be pretty incredible. And it'll be a place, where everybody, regardless of their mobility, whether they're in wheelchairs or not, are going to be able to come and sit and watch and enjoy the presentation. Right now, we're limited. We have people coming into the observatory. They have to be able to be mobile. They have to be able to stand up, sit down without assistance from us. Because the administration here does not want those of us who are residents to get injured helping other residents. So they're saying, you can't help people. They have to be able to be on their own.
So if someone
The other thing that's
look down at them and laugh, huh?
right. The other thing that's really been interesting is that as a temporary thing to show people deep sky objects, I put the video image on my laptop and then put it up where people can come outside the dome and where the slot's open. I put the computer up there and they can look at the screen right there. And I can, like we were looking at the Orion Nebula, and I can adjust the exposure time on the camera to show the trapezium and then gradually show more and more. So I can show the innards of the nebula and then show the extents it grows out and just let it expose more and more till you get this, much bigger picture. And
Bob,
so
you're talking about using that Atik Horizon camera?
Okay. Yeah, to clarify, I have two cameras by Atik. I have the Infinity, which is still being manufactured, which has been a big success for Atik. It's an entry-level camera. In terms of photography work, it's entry-level, but in terms of public showing, it's great. I mean, because it's a CCD, it's very easy to operate. And with their Infinity software, where there's a stacking that's done internally, you can control how much of an image that appears. You can have it more exposed or not exposed. And you can do all that in real time as you're explaining things to people. So it's an amazing teaching tool. So the Horizon camera I have is no longer manufactured. Then there's Horizon 2, I have Horizon 1, and it has higher resolution. But right now I'm using the Infinity camera because I think it's easier to use and it does the job. So one of the unexpected neat things that happened is that as I was showing people the pictures of the Orion Nebula, they started using their smartphones to take pictures of the nebula, on the screen of my computer. And I said, that's a cool idea. I said, go do it. You'll have a neat picture of this that you can take with you and look at it later. And they did. They got some great pictures of the Orion Nebula from the screen of my laptop. And so one lady sent me her picture and asked me if I would kind of square it up. And I said, sure, I'll fix it for you and send it back to you. And now she's going to have it printed, and so she can put it up.
Bob,
So
you should start charging money for that.
Right. Oh, man. So anyway, what I'd like to do, after we get it all hooked up and operational, I'll put together a slideshow kind of from beginning to end to show it how the thing all started and came in a crate and how it assembled and then what we did to get it going. And I can show you the pictures of the TVs in the room. And anyway, I'll put something together maybe later this month and where I can do a show. Either I'll do it or I'll send pictures to Tom and he can run the pictures and give you an idea of how all this came about. But it's really what's really gratifying to me is how wonderful the residents have responded to this. I had no idea that people would be so excited and find this so interesting and meaningful to them. I mean, it's like having being a public star party twice a month, where you have people coming and getting very excited and looking at this stuff. You all know what that's like. It's a lot of fun and it's great to show people. So that's sort of a quick update of where we are.
Okay.
The switch that I was referring to with Jerry is that in order to, I have to get outside of the observatory in order to get into the room where the TVs are, so I can narrate what's going on. But in order to do that, I have to get outside and then close the dome up, or not close the dome up, close the door and put the thing over the door so the track it'll follow across that. If you don't do that, it'll just come off the track, the old dome will. So you have to put that door back with the guide on top of it. So here I am outside, but no way to operate the dome. So we put in an external switch and I got the wiring from the owner or the manufacturer, checked it out with Jerry and, what he thought about the wiring diagram. And he said, it looks good. So we did it, we put together. And so now we have a toggle switch outside that I can turn, that I can rotate the dome externally. And also that's a good safety feature. If I'm in there and something should happen to me, need to get in there, then they can operate the dome. They can turn the dome around and open the door. So, so anyway, that's what that switch was about, and it works really well. So we got
Good.
that taken care of. Yeah. So anyway, that's sort of a quick update, and but I'll put something together and share photos with you and all that later, and you can go into it in more detail, whatever you want to do. So if any questions on whatever. I know, Jerry, you're just about finished with your observatory, right?
Yeah, the contractor was here today and we chose the paint color from a paint palette for the inside, and Pat picked the color for the outside. And they're about to install a combination door opener, that deadbolt on the door. You just punch in the code and it opens.
Great.
And,
So
and,
you're
then,
just
and then we're done. Then I start
wow,
putting the telescope in.
wow. It's great.
So Jerry,
Pleasure.
did you say you ran a conduit from your observatory to where? Where do you run your conduit to?
Well, we have two conduits. We have a data conduit and a power conduit. The power comes in from the nearest wall in the house and comes in and has a set of plugs that we can plug in the observatory. And the data conduit is a Cat4 Ethernet cable that goes from the observatory down the side of the house and into the ground floor Pat's office in there, which is where our house modem is. And then it goes into the modem, and then I can pick it up on the Wi-Fi in my office or wherever I am.
Goes into a Ethernet switch, I guess. Yeah,
Just a modem.
it's
That
just a
sends it
modem.
out to the whole house. I don't know that modem is the right term, but it's the thing that you put your Cox cable up to, and then it sends the internet information Bluetooth throughout the whole house.
Yeah, yeah, the Wi-Fi router probably.
Yeah, yeah. But we had a modem and a router in the same box.
Oh,
So-
Yeah.
Most of them do.
So how
Okay.
far is it?
you'll be able to run this remotely, Jerry, from anywhere in your house?
Eventually, yes. I could sit outside with my laptop, I run it out there because we get good Wi-Fi reception out there from the house. So not enough space to comfortably run it from inside the observatory, but that wasn't the plan.
Mhm.
So
Excuse me. What are you using for your controller option for the telescope when you're using the Wi-Fi?
I use the software and drivers supplied by Astrophysics for their mount. And I use the software for Moonlight Focuser or Optec Focuser. I have two. And then I use the camera software through Nebulosity 4 and the guide camera through PhD 2 or something, whatever it's up to. So
And it's a 14-inch, right, Jerry?
it's an 18-inch F3.8.
Oh, wow.
And it's, or I can put in my 12.5-inch F6. They both fit in there. And
Wow.
other scopes fit in there too.
18 and 18 F3.8. That thing is like that's a cereal bowl, huh?
Well, it looks like, yeah, it's noticeable.
Yeah.
It has a paracore on it. And that adds 15% to your focal length. So it acts like about an f4.4 or 4.5.
Oh, nice. Those paracores are not cheap.
No, but they sure are sharp.
Yeah, yeah.
Get the spacing right.
I kind of dread that if I ever get into that 16-inch blank I've got, I've been told you do that f16, and if you want to really make it work really well, you're going to need a paracore. It's going to take that.
What's the focal ratio on it again?
I have a f4.
Yeah, you're gonna, if you want to take pictures to the corners and have them show up as little sparkling stars and not flying seagulls, then you're gonna need a paracore.
And they're at least 600 now. I think they are. They're more than
400 or something.
Yeah. I know they went up. I was shocked.
Everything's going up.
Yeah, it is. It is. Well, that sounds really neat, Jerry. That really sounds neat.
Yeah. I'm
You know,
looking forward to it.
What Bob was talking about, how, things that, you go to the public and you just say things. I went up to the Mesa to get one of these Shingrex, the shingle shots today, and didn't know that I had to schedule it. So I ended up getting a shower cap for the scope that, because that's what Tom Whittemore uses, just a shower cap to go over the top.
Yeah.
And I'm trying to explain this to the girls in front, and mention, I said, all I'm doing is covering a scope to keep the dust out. And this one girl just out of nowhere, she goes, "That's a really good idea. Is that your job? Do you do that for a living?" And I went, "No, man, this is just an astronomy club." And you end up telling them about outreaches and all the star parties. It's just like Bob said, it's amazing how it just flourishes kind of all on its own. It's amazing. I hope you guys get a chance to share with us, Bob and Jerry. I hope you get, and Ed, I got in late. Did you fix the problem?
Not entirely. My auto-guiding scope is not seeing anything.
Huh.
That might give me some good ideas for.
He's moved on to
Looking
more
and testing it.
sophisticated problems.
What's that? I missed that.
Oh, I said you've moved on to more sophisticated problems.
Yes, I would like to. By far.
And hopefully within a week, I'll be up in business again with my observatory.
No.
Because I was waiting till after the trip, which I didn't go on, to put everything back together in the observatory. I did get enough resin again to go and put another layer of fiberglass on there, but I think it might be strong enough that I could use it without it falling apart again. So yeah, I think I lucked out with that.
So Ed, I used the PhD guidance system with an Orion camera for many photographs I took when I was in Santa Barbara, and it worked really well. And I was listening to you. I don't know what's going on that you're getting no image, because you should see whatever you're looking at. In other words, if you've got a star field, it's only you see stars, and you have to put the stars in certain parameters, which PhD sets out for you, and you should be able to see that all on your computer screen.
If it's way out of focus, though, the stars are so diffuse that you really can't see them. I've run into that a couple times.
Yeah, that can happen. So, like I think Tom was saying, you can in the daytime.
Yeah.
What I used to do is I would align it. I check out the alignment to make sure the camera was properly aligned with my big scope, because I had a separate guide scope, and I would aim it at very distant trees or bushes, a long ways away, and then I would look at the image in the telescope, and then and then the image that I would see through the guide scope, and and then focus them both so that they have the same focus and everything's very clear in both of them. And also you can make sure that your guide scope is properly aligned with your big scope.
Yeah.
And so you should be able to see that unless there's a defect somehow in the transmission of the signal from your guide camera into the computer. You should be
I
able
like
to see
Gary's
that.
idea. I've had that problem where it's way out of focus and it's like there's nothing there. So that's a good one to check.
Let me inject here. I took the ST4 cable off and I hooked up the guide scope directly to my software to view directly through the autoguider, and I focused it. And then I went back and I hooked it back up the right way. So it should be in focus and it should be looking at the same object.
But it wasn't. Okay, then let me ask the obvious. Did you take the lens cap off the front?
I double checked last night. I did have it off, didn't I? Yes, I had it off. It's in the house. It's not even out here with me. But it
Then
does
I would
look like
check-
it does
I
look
would
like you
check-
got
Help you.
Then what I would do is go to the control and turn the gain up to 100% if it isn't already there. And that should give you the most amount of detection with your camera with PhD guiding.
What do you mean like right now the sequence is at 1 second?
Yeah, but you don't know what the gain is.
Right.
And so the gain goes from 0 all the way up to 100%. Most of the time I operate it at about 70 to 80%, but you can move that slider all the way to 100% just to make sure that's your sanity check.
Okay.
And also, there's another slide on the display picture. You move it back and forth. There's one way where you can move it where it just lowers the threshold of white and black on there. Maybe you had that slid one way or another too much. So those are two places where it's possible to make things look kind of bad.
Okay. Okay. I'm gonna check on my meal.
Yeah. So, do you ever figure out who put the names on the lunar maps?
Tom, I think that's directed at you.
No, to anybody.
Oh,
The Sea of Tranquility and the Sea of Serenity. And
Yeah, but who gave them those names?
I think they were given over over several centuries.
Actually, relatively
early Galileo.
just after Galileo. Okay, so we have this thing here with Harriot and Galileo. I'll bring it up to it. The next lunar drawings were by Shiner, and then Michael Florient. Now, he gave them names, okay, that were, because he was, most of these guys were very religious, or they were, Benedictine monks, or I forget, they were part of the Catholic.
Lunar Truth.
Yeah. Anyways, this guy, because he gave all the names to Catholic royalty and saints, and that didn't stick well. Hevelius named features after Greek and Latin names.
He clearly saw the libration.
Yes. And so later on, just a little later on, this is where we get most of our names from. Grimaldi and Riccoli. And both of them were with the church, but they agreed with Hevelius that it shouldn't be just about religious people, but scientific or other type of people. So they
Let's see some of their names. Show them up close. Can you expand that? I can see the Caloris Basin.
I will show you in another picture that's closer. Okay.
Okay.
Okay. So Riccoli and Grimaldi. Okay. So what they figured it should be people of science or astronomers, and so they basically what they did was they were systematic. They cut the moon up into 8 zones. They had the name for seas and plains for historical names. They were named after that. Craters after scholars, mostly astronomers, and a few saints connected with astronomy, just so that these people, you know, were a little bit mollified. So, so here's one of the close-up, and you can see Nectarus and Terra Mare Tranquillities, and a bunch of Tycho, you know, I'm having a hard time reading, you know, but basically these are the names that kind of stuck. Okay. So most of it, not all the you know, features were named at this point, just the large ones. So this brought me up to another thing that I discovered. Who was the first to measure an altitude of a feature on the moon? And it was Galileo. But he didn't, he tried using what they call similar triangles, but he didn't really do much with it. The first guy, oh, and if you're wondering how I found out about it, I found this place. It's called True Anomalies. Okay, it's kind of a weird thing. It goes off in the Netherlands, so to speak, but a lot of interesting information on ancient science. But basically, this is what Galileo thought. And let me minimize so I can see the whole thing here. So you can see what he tried to do was figure out that if the observer is looking down at the moon, the sun is basically shining this way. So this half is sunlit, the other half is dark side. So from the terminator to a feature, he figured, well, there's got to be, since the moon is a sphere or spherical, that this feature must be in altitude compared, otherwise it'd be in darkness. And so he started with that, but Hevelius really did a major study on it and calculated some of the first large features by using the fact that the moon, he was looking at features at quadrature, okay, where the moon's directly shining across here. This is all without sines and cosines. So anyways, he recorded, but it was Herschel that came up with a more complicated way of doing it, and he was able to figure out features no matter how the moon was illuminated. And again, using similar triangles where the sun shines down here and you've got a triangle like LMR is similar to, I think it's LO, no, ORM, I think it is. But anyways, he was able to do that. So he wasn't just finding deep sky stuff. He did some interesting things with the moon.
So when did they first measure distance to the moon? How far the moon was away from the Earth? When did that happen?
You know, I need to go put that down somewhere. I didn't write it down. I'm sure 2 astronomers looked at the moon and just used parallax, maybe. So another one was Schroeder in 1791, and he went gonzo on this. And here's 2 diagrams from his book that he wrote. The one on the left is sort of like, how do you calculate the height of the mountain given the latitude, longitude, and the sun angle. And the other one was, he did a very deep study of all the craters, where in this case you can see the rim of the crater on one side and the other, and did some careful measurements.
So
And
at this
so
point, do you think, when did they stop thinking that there might be water on the moon?
I think it was before this time. I think it was sort of like Riccoli and that, simply because they were starting to see like domes and stuff like that.
They could see craters inside the
But as you
seas.
know, it was up to about the 1800s. I guess Flammarion and all that was writing about creatures on the moon and all that. So here's and Schroeder thought there was life on the moon, and so he went overboard in the way that he drew it.
Like, he's the first one with a good telescope.
With the what?
He's the first one with a good telescope.
Probably, yeah. And so so he basically overdrew it, so to speak, but a lot of the features that he put on are accurately positioned and shaped. It's just that he came to wrong conclusions. And so then what I did was, there's in a couple of colleges where they take a small telescope like an 8-inch LX90 and some reticle eyepieces and a stopwatch. The students are tasked with calculating the heights, and also they do use a CCD camera. So for some astronomy courses, it's sort of like one of the rites of passage is to calculate the height of features on the moon. And so some of this information I found on this website, Renaissance Mathematics, which had a ton of stuff, a lot of interesting things about what was developed back then, and for those who are lucky enough to have hung on to their rookie lunar atlas, I discovered this website where you put in your time and day and all that. It lights up the squares which correspond to the pages in the atlas to show you where you can look for things on the moon. So I thought that was pretty interesting. And this one, for those who don't have Rookie, the virtual moon atlas. This is a really great website, and I've got this software up and running, and it shows features, and you can simulate dates for when you can, what's on the terminator and things like that. And just it goes much further than Rookie on information about the moon and features. Although I think Ruki does a better job of making things visible because he touches up things to make them look more visible. But this is a good one, and they're up to 7.0. I've been using 6.0 and a ton of stuff. So that's it.
Very good.
So you know, like I said, you know, you I don't know about you, but when I go say I'm going to go talk about something, I always go off on this tangent. There's always something else that's kind of interesting. Like one of the things I might have time to learn a little bit more about is the geology of the moon and all that. And there are websites that I should show. Hold a second here. That talk about. Remember talking about all those elements that were on the crust of the moon. Well, there's some good papers on there that talks about that talks about the you know, the intensity of the gamma rays emitted by these places, and a map of the geology showing where the deposits of these thorium and other elements are. So, you know, I just in a way, this club, even though it's like a lot of work, it's sort of like an interesting deep dive. Because I have to come up every month. I have to come up with every month with something new, and the next month after that is I'm already working on it. Is on occultation. You know, why occultation? How to do occultation? And I you know, I'd like to have what's his name from the SBAU give. Yeah, Partland would be, you know, see if I can contact with him. But yeah.
You know, on the Shallow Sky site, I tried putting in www.shallowsky.com and it didn't work, but without the www, it works.
Weird. But it's you know, you start looking at things and all of a sudden you can waste half a day. No, not waste half a day, but you get sucked into it. You know, very interesting things that is just so much to learn.
Yeah.
I mean, so
The thing is, they're discovering new things at a rate faster than we can learn the old things.
yes, yes, because, you know, during the time of Laplace, or you know, even up to, let's say, the middle 1800s, somebody could know everything just about I mean, everything about astronomy that was really important. And here now, it's just you just go through the Webb telescope pages and you start learning about all the different techniques that they're using just to observe things. And you know, like with the Webb telescope, they're breaking the 1.22 arc seconds per inch rule by going to a form of interferometry, as you know. I did talk about that to you guys last week or the week before, right?
I don't recall.
Yeah. I know. Yeah.
I must have been there that night.
Yeah. There's the equipment on the Webb telescope. Okay, I guess I didn't. One of the interesting things about the Webb telescope is that it's got a cumulative, non-destructive readout. In other words, if you wanted to find out something about the Orion Nebula, okay, you can continuously read it out as the image is building up. So you never get, you never lose your dynamic range. Things don't get lost in the glare. So those sensors they're able to.
It's a sensor that cannot be saturated.
That's true.
Yeah.
Well, actually, you usually run out of the binary word.
Now, there are ways to make focal planes that do not saturate. They can look at the brightest object and the dimmest object at the same time and give you the measure of their brightness relative to each other.
Yeah, well, this one here, it's continuous, and
Yeah.
and so they could have it on for hours. Here, let me jump out of exit full screen. Go to my previous months.
This one you were talking about, the Ruckel,
Yes,
that's
you got the later version. I only have the older one.
Yeah, I got the later version. This thing was nuts expensive. It just went. They stopped the edition. They stopped publishing it,
Well,
and it just
remember,
it just went through the roof.
at the beginning of the year, I think it was like $600 or something like that.
Yeah. And
Yeah.
I got this for like, I don't think it was $30 or $60.
$39
Yeah.
is,
It was incredible. And then after that, the one that you have, the original one,
yeah.
that thing was crazy expensive.
Well, I've got a couple books that are worth $800. That I paid maybe $40.
Oh, there you go.
for.
179. That's come way down.
Yeah, hold a second here. Oops. Oh, it's only worth $179.
Yeah, it's way down.
Yeah, you should have.
Yeah, at some point it was like $600, and I was going, whoa. $4.99 used.
Okay, here, hold a second here. I guess I didn't show this to you. Hold a second here. Let me just show you a couple of things, because I guess you guys. Here, a second here.
Was the transit of Venus, was that used to originally measure the distance from the sun to the earth? Is that what that was used for? Or the diameter of the earth?
I forget what the measurement was.
Okay.
But
Okay.
it wasn't the moon. It didn't do anything for the distance to the moon.
Nope.
Okay.
Do you see this here on
No,
the screen? Okay, hold a second here. Hold a second. I've got something on the screen here. Hold a second. Oops.
yeah, sometimes I think I'm sharing something and I forget to get it shared.
Okay, well, I'll just do this one here and just make it bigger. Okay. I told you guys that I didn't believe that the Webb telescope was going to have a normal star image, and so Richard Berry and I went and simulated the telescope, and what you get is sort of like a starfish type of thing. And so that was like in January.
Uh-huh.
So this is the first image of the Webb. And here they're getting it closer and closer. And if you zoom in on here, you can see that you're getting smaller images. And this is where they got it pretty good as far as the collimation. And what they did was, whoops,
Mike, what does PSF stand for?
Yeah.
point spread function.
Oh, yeah.
That's what the telescope will make a point look like. It loads it, okay? And so this is the point spread function that I discovered after I asked Richard. This is for the mid-infrared imager at the various wavelengths, because the diffraction changes with the wavelength. You can see at the over here the lower, I should say, the higher the frequency, the smaller the spot, and this is the lowest frequency that it can see. You can see it does change, and as per the equation, you know, that we used to calculate the 1.22 and all that other stuff, you know, the area just does get bigger. Okay, and so, oh, I don't have it here. Doggone it. Basically, I did this before. They came up with a picture where they showed the actual star, what it looked like. It looked like it looked like this exactly. You know, almost exactly like this. You know, but one of the things that I did, you know, I kind of realized about this Hubble, I mean the Webb telescope. It was designed to cool its optics, and everything that went into design after that supported the cooling of the optics. It is at Earth's orbit, it is now the coldest object within Earth's orbit, simply because of the design of it. Okay, and the reason is that they wanted to use radiative cooling to reduce the temperature of the optics. And the reason why they needed to reduce the temperature of the optics is that the heat of the optics would be far more powerful than the objects they're trying to look at the edge of the universe.
Yeah, and swamp the signal.
Right. So everything about the Webb telescope is to that end of reducing the temperature without a refrigeration unit like they do on the Hubble telescope, which uses a lot of power. Okay, so the first thing they thought was, and we all fight it here, we try and do the opposite. We try and keep the heat within the telescope. And so the first thing they did was they threw out everything that covered the telescope. Everything radiates heat away as it can from the optics. So it's an open design. So the heat radiates away. And in order to do that, because things can come in from the side and blast it, okay, like the you know, Earth or moon or the sun or other bright objects, they needed a way to keep heat away, because the moment that the sun shines on the telescope, it heats it up to 180 degrees Fahrenheit in some cases. So the two enablers were the Lagrange orbit and the efficient solar shield. Okay, those are the two most important things about the design of this telescope. Okay, forget about the fact that you got multiple mirrors and fancy cameras. These are the two things that are driving it, that are the main drivers of what it can do. Okay, and with the Lagrange point, okay, the telescope is going to be further than the Earth by about a million miles. Okay, and the reason for that is that they would not be able to make the shields work the way they do otherwise. Okay, and the reason is that they never want the telescope to see the light of day. So the Lagrange point is orbiting in this sort of like hollowness of gravitational pulls. Okay, there's a Lagrange point here where the pull of the sun and the Earth equals out. There's a Lagrange point here at L4 and L5 because the Earth is moving in respect to the sun, and L3 here for some reason. I guess there's the mathematics work out that there's a gravity hole here. So
you know, Mike, we we on our Monday shows, quite a few times we've gone over these Lagrange points
Okay,
with our folks, and it's been pretty interesting. So
okay,
we've seen this a lot.
Okay, so the solar shield, okay, works. Okay, the reason why it's got multiple layers for the solar shield is that whatever residual heat's not reflected off gets reflected back and forth through these openings. Okay, and so 100% of the sun here may be 1,000th of a percent of the sun and 1,000th of thousandths or whatever. So in other words, the multiple layers allows this side to cool off. Okay, and as you can see here, at this point, this was weeks ago or a month ago, it was at minus 390. Okay, where at the other point it was like 127 degrees Fahrenheit. Okay, and one of the features of the optics is that it can't move with respect to the spacecraft. So you need to move the spacecraft to point everywhere. Okay, just like with the Hubble, but it's different. Okay, the difference is what they call the field of regard. And at the meeting, Tom, I talked about that, where everybody, if you look straight forward, you see your screen. Look to the right, you're looking at a wall or something. Looking to the left, you look up, you're seeing the ceiling. You look down, you're looking at the floor. What you're doing is you're paying attention. You're given a regard to what you're seeing. Okay, so that's the name of the game, what they call field of regard. Okay, the field of regard of this telescope is not like the Hubble. The Hubble can point just about everywhere except for the sun and the Earth. Telescopes on ground, we can look at just about any place from zenith all the way down to the horizon, all the way in the azimuth. We've got this entire, half of the hemisphere we could look. The Webb can't do that, and the reason is that it has to allow the heat shield to work, and so it's got a very narrow field of regard. Okay, so in other words, it can move backwards and forwards just a little bit, and tilt and yaw and rotation. Rotation can go 360 degrees, and so it's very limited of what it can see at any one given time. And so it takes about 6 months for it to see the entire sky. Okay, so if you miss an object, you have to wait 6 months until you point it, rotate it, and point it just a little bit back and forth. Okay, that way the sun is always, the shield is always pointing towards the sun and protects the telescope. And of course they use gyros and reaction wheels, and there's a solar sail too to help point it. So that's basically, the main drivers of this telescope, other than the fact that it's got folded optics. It's got multiple panes that work as one big one because it couldn't fit it in a rocket that they were sending it up. So but basically I'm going to stop sharing. So basically, there's a lot of information that you can see on the web with respect to the Webb telescope. They actually give you instructions on how to use the instruments. You can, if you want to, say, I want to look at a certain object and come up with the information to say what camera you can use, what filter, if you're looking at spectra, which diffraction grading, and how to also operate its in front of some of the cameras are 1,000,000 shutters or something like that. Yep, there you go. Okay, so another thing too is the cameras. There's a shutter like the old style projection TVs in front of it, and the purpose of that is to allow you to block out all the objects that you don't want to see and see only the ones you want to see. And what they're using that with is like the spectrometer, because the spectrometers are set up such that the entire field of view of that camera it shows the spectrum. So if you want to single a certain star, you only open up a window where that star is so that the other ones don't clobber each other. So, and it's all on the website. There's a couple of websites, and believe me, there's enough information that you could spend years just looking at the inner workings of this telescope. It's all very well documented.
I can't believe that the operating temperature is 7K,
Yes,
7 Kelvin.
yes. Literally, it's the coldest object in Earth's orbit area. It might be the coldest object intentionally in this solar system. I mean, because yeah, Mercury's got extremely cold, but it's connected to a planet that's being heating up, and there's mass. Okay, the moon has ice on there because it's exposed and it's super cold, but it can't be as cold as 7 degrees Kelvin because it's connected to a body that has a core and is getting heated up and cooled off every place. So it probably is the coldest object in our solar system, just because it's designed to radiate all the heat away all the time, and it's not connected.
I'm looking at this thing about Pluto, and it says that the temperature varies between 33 Kelvin and 55 Kelvin.
Okay, see, much warmer.
When they, excuse me, when they designed the mirrors, did they have to worry about the curvature? I'm sure they did.
Oh yeah, here's another
They
thing too.
did a theoretical there.
They modeled, okay, first of all, the mirrors are made out of beryllium, okay, extremely light and does well at cold temperatures. They knew that each of these sections was going to change as it cooled down, and that they couldn't get it as cool as they wanted to and optically tested it. So what they did was they modeled it, and each of those segments, I think there's like 6 or 7 different types of segments that you fit it all around there. Okay, there's some that are duplicates of each other. So they polished it so that it was not correct, but would be correct when it eventually cooled down to the proper. Isn't
That's
that
thinking
crazy?
ahead, huh?
Well, $10 billion.
Wow, the 7 degrees
and
sounds like a pretty hard target to hit.
And,
What do you
and
mean
part of the
it's
way
harder?
through, and part of the way through, they started all over. They ripped up the page and started all over again. But I mean,
when you go through all of the mechanisms that had to work in order for it to get where it is now, and they said that it's actually more efficient than they planned. So it's actually, instead of I think the original 5 years of life, it's 10 years. I mean, this has got to be the greatest engineering and astronomical feat that human beings have pulled off. It's got to be more complicated than putting a rover, on Mars. When you go through all of this stuff that had to work for it to get where it is, it's just incredible. I was reading Sky and Telescope had a detailed piece on this, and I finished reading the article, and I thought, they're just going to be damn lucky if this thing works,
Yeah.
But it's amazing. It's just amazing that it is, and not only it's working better than they thought. So kudos to everybody. My gosh, it's really, really amazing.
one last word about the Lagrange orbit. It's not really at the Lagrange point, okay, or the actual orbit. They purposely placed it slightly closer so that they needed thrusters to constantly push it back to where it was supposed to be. And the reason is that they didn't want to put any rockets on the telescopic side. So if it went too far, they wouldn't be able to move it back because of the fact that the plume of the rocket would contaminate the optics. So it's always slightly in, and they're always moving it out a little bit just to get it to where it's supposed to be. I mean, it's just so much thinking that went into it. But you can go to the website, and there's really an instruction book for the Webb telescope. Okay, and they give instructions on if you want to do research, this is how you write your proposal and tell them what cameras there are, and you go click, and here is the instructions for using this camera and the other, and how you move the carousel around, and what to expect, and the sensitivities, and all sorts of.
I'm going to have to check out here. It's very interesting.
Okay.
My dog is calling me here.
Okay.
See you later. See you next
Okay.
week.
So anyways.
Hi, Jerry.
So anyways, I'm going to talk about occultations next month. So I got to get up to speed, do a deep dive. And
Yeah, Chuck has done those talks to us. We probably have a recording of him doing a talk on occultations on our website, on my YouTube channel, the SBAU
Right.
unit.
right.
You could take a look at that, in fact, and see.
Okay. Yeah, there's the IOTA place, and one group that's starting to do it is the group with the EV scopes. They're not only doing photometry, they actually have a section that's doing the occultation timing. So I thought that was pretty interesting. I went to the IOTA site. A lot of interesting reading.
So Mike, it's interesting. On Chuck's, he did this show here, December 2018.
Okay, hold a second. Let me write this down.
Well, you can look it up somehow. Just type in SBAU meeting McPartland occultations. But this video has the most views. It's got 1,226 views, but probably because people were looking for the occult type stuff. And if you look at the analytics on this, you see how many people actually stayed through the video. It gets cut off pretty quickly. People look at it for a short period of time and they go, "Oh, that's not what I really wanted."
Yeah,
I'm not into it.
I'm constantly asked, "Oh, you're an astrologer?" No.
Now look at the average view duration was 17 seconds of actually. So you get all these views, but the duration is just nothing because
Well,
it's
he's really
not what
great
people.
at getting his point across real quickly.
Yeah.
Oh,
But yeah, if you review that, it
Yeah.
might give you some ideas.
yeah.
Yeah.
Well, actually, what we're going to do with our club is later that month. There actually is going to be occultation of a 5th magnitude star, I believe, or is it 6th magnitude star, and we're having a star party for that. So we'll have a video camera, and I have a 34-inch TV that my daughter wanted to get rid of. What's nice about it, it weighs only like about 10-15 pounds, so I'll take that wherever I go and set things up, and whoever wants to look at it at the local astronomy club or the trilogy can do that. So
I talked with Chuck before you do that. He has so many negative, there are so many negatives that pop up, and when you get a positive one, it's just a wink out of a star.
oh yeah,
And it's so short.
no, this is a lunar one, not a asteroid.
Oh, Oh, okay.
Still,
Yeah.
Tim, it's kind of cool that Chuck gets his name on these scientific papers because he's adding a data point to measure the size of an asteroid or whatever.
Yeah. And also a negative instance is
It's
of scientific,
a data point.
because,
Yeah.
because,
No, that actually helps.
yeah, because believe it or not, the first, satellites around asteroids were determined by occultation. So, and when you think about it, we have many more chances of seeing the shape and determining like rotation and stuff like that as amateurs than the professionals do, because they can't afford to.
Yeah. Citizen science.
Citizen science, yeah. It was kind of interesting reading the IOTA website, with certain warnings. People may come up and give you an issue. Sheriffs may come up and
Yeah.
bug you.
Yeah. Chuck has a really good story about one time he did a star party out at UCSB. Like near the Francisco Torres Towers. And he had a cop stop and ask him a bunch of questions. It was really funny. Maybe he'll share it sometime. It's a really funny story.
Well, I have to admit that, some of those comet pictures I showed, I went to the Montezuma Hills at a gate of a ranch, and we had set up, and it was just at sundown. This pickup truck comes by. It was the farmer. What you doing here? Oh, I'm setting up a telescope and taking pictures of the comet. So he probably heard the news about it, because I think it was Comet Leonard, was very famous. And he saw my telescope that was all set up. So he says, yeah, normally people here shoot drugs, and I have to go pick up the needles here all the time, Yeah, you can stay.
Well, it was funny. You were mentioning star parties and the things that people bring up. And the last star party I was at, this couple came by and they'd been drinking, and she says, I got two questions for you. First one is, what did you think of the movie Don't Look Up? And I said, and I was kind of down on that. I just said, I didn't like it that much. It's the usual thing about science versus politics, And then the second question is, well, what do you think of astrology? And I was going, don't say it to that guy over there, and it was Chuck, and I just said, it's the reason you're going to hear a lot of people say, poo-poo astrology is because what it was originally intended to do, it probably was some type of astronomy back then. And I was trying to tell her, look, all the different constellations that they were supposed to tell you who you were and what month you were born and how you're going to behave and all that. And I said, those constellations are not there anymore. They're in a different place. So, I said, they had to rewrite everything in astrology now, because they had to create a 13th constellation because they realized they were all off, and boy, she sat there and defended it. And I was going, wow.
No, astrology and the religion and politics.
It was they were all hot buttons. And I was telling her about other star parties that I'd been at, about UCSB out to Cali Real, and how the people that came by there, you have all kinds of people from all over the world that come there. And I was saying there was a couple of Arab guys that came, and they were acting really weird towards me. And then just out of nowhere, this one guy said, well, Muhammad made 2 moons rise one night. And and I didn't respond. I just kind of sat there, and they looked at each other like, see, told you, here's a Western mind. He's not going to say anything. And then suddenly I blurted out, well, yeah, we got a guy that walked on water, and parted an ocean. And I said, you're going to find that.
Very good.
And I just said, look it, you guys should really be proud of your heritage. Your ancestors, they named some of the stars. And I said, that's incredible. You know, and I started making, you know, I started talking about Denebola and you know, how they were named. And I think I caught them by surprise, you know, and just saying, you know, these guys, they're all, you know, they were out in the deserts, you know, and you can see a ton of stuff out in the deserts, you know. And then I reminded them, here at Cali Real, you're lucky to see the moon, you know, from all the lights. Anyway, that's enough for me. It was fun.
Well,
Well, we've reached 9 o'clock, so what do you
Yeah,
think?
yeah.
Call it for
Can I
tonight?
inject one question? Did
Sure.
anybody see the conjunction of Mars and Saturn?
In the
No.
morning? Are you kidding? Who gets up that early?
it's
I did.
been cloudy.
Tom might have. Tom Whittemore might have.
Yeah, he does. Yeah.
He gets up real early, and he's been testing. He's been using this a 92 refractor he has on a Ioptron. No, on the Gemini mount. So he's kind of starting in using this little dinky refractor, 92 millimeter, and we're going to be doing a little bit
It's
with
nothing
him.
to sneeze at.
No, it's not. And we're actually we're talking about another little refractor night that we're going to be doing, and we'll go up to his house and just bring a bunch of refractors. It's kind of fun. He's got a fairly good southern view, and you know, those, as you know, down here, those are kind of they're far and few between.
Here's my way of looking at Mars and Saturn getting close together. Venus.
Yeah.
It's a little different at 4 in, or actually 5:30.
If there's-
it seems
there's no
dimmer
fog,
because you
yeah,
can't
it
get your
was-
eyes open.
There were trees though.
Hey guys, have a good evening. Okay.
All right,
Okay, we'll see
ending
you.
the meeting now. Talk
All
to you
right.
soon. Bye.